What's up, YouTube? This is my C++ Minecraft clone, and we'll start with a summary for people that are watching this for the first time. And then new viewers will vote what we're going to work on today. And at the end of the stream, which will be in about 3 hours, we'll do a summary of what happened today in this stream. I'll start with a quick summary. This is in C++ in Raylib. And we've worked on this for about 2 months, this project. We have terrain generation, which uses 2D noise. We have clouds that are just a simple texture. They're not 3D. We have caves, which are just purlin worms. They're very simple caves. We could improve them. We have village. We have a village where it's very simple. It just has a center, which is a fountain, and from that center we get these roads, and to the left and to the right there is a chance a house spawns, and the house is temporary. It's temporary. We have support for structures. That's how we get these trees. These trees are using structures. Also, we have support for texture packs. This here is the bare bones texture pack. We on the other times we use the faithful 64 resolution, so we can have even higher resolution texture packs. And we also have support for animations automatically. No matter the animation, we have it. Even this Coke block, we have the animation for it. You can see it gradually changes colors. And what else, chat? We have we have here a chat. Hello, chat. And whether we can do a command, we have only one command. We have only one command, which is summon creeper. We have this creeper, and we have TNT. So the creeper is just static. He stays in one place, but we have the TNT and it's working. So we could easily fix the creeper. We can easily fix the creeper. And he collides with the ground. Also, we have particles. If you can notice, we have particles which change with the block we are breaking. They actually change. Here we can see it's using the this lock. Anything else, chat? We have redstone as well, and we have rails. That's cool. So if I put this piston and if we give it signal, it moves, and it also moves other blocks. It also moves other blocks. We have this repeater, which also gives and removes signal. We also have the rails. We have rails. We have rails. Which they can get powered as well. They can get powered, but we don't have a minecart. We don't have a boat as well. But I like it how it is. I like it. We have also custom block hover, which is my favorite feature. Okay, how now we are targeting the block and now we're not. Now we are targeting and now we're not. Now we're targeting the blocks behind it. So that's pretty cool. Here's some culling issues, but I don't care about that. And also, we have fluids. We have fluids. This is the lava. This is the lava, but it stays in one place. We attempted to do liquid physics, where the water spreads infinitely. Yeah, so that's kind of a summary for people that are seeing this project for the very first time. And we'll do something different today, chat. Usually we brainstorm ideas. Usually we do that, but now I have a different idea. For this stream we'll do something else. We'll not be brainstorming, but we'll be voting what to do. We'll be doing a vote. And here, let me open this. We'll open previous ideas. and I'll pick 4 ideas directly. I'll pick them, but you guys will do the voting. But I'll pick the 4 ideas, and we're not picking multiplayer. So here this option gets removed. No multiplayer chat. And mod support, no mod support. Bro got tired of multiplayer. Guys, I see here some jewels being sent here. I think this is some kind of support. I appreciate that. I thank you for that. I assume this is some kind of support. Yeah, so I'll create a poll, but you're getting destroyed, man. Add user. You are gone, man, forever. So we'll do a poll, but I'll pick the options. I'll pick them. What to do today? I'll pick the options, but you'll vote. You'll do the voting. You'll do the voting, guys. So the options. One option is to finish water physics. This is one option. Another option is villagers. Another option is creeper path finding. And another option is either 3D Steve or fireworks. Which one, chat? Either 3D Steve or fireworks. Mm, 3D Steve. 3D Steve. Okay, chat. Pick what we're going to do today, chat. These are the options. These are the options, chat. Let's see what chat decides today. We'll wait for everybody to vote. We gotta finish something for once, chat. Yeah. So chat decides what they're going to do. Chat decides what they're going to do. How are we getting 35 votes when there are like 30 people here? How do we get so many votes? Okay. We're ending it then. We're ending it. Right, chat? In 3, 2, 1. Okay. We're doing water physics. We're doing water. We're doing water. Okay, chat. Chat has decided we're doing the water. Let me bring out Minecraft for reference. Let me bring out Minecraft for reference, where we can look at the water. And from the previous streams, somebody gave a brilliant suggestion to use a shader pack that makes the mesh a lot more visible. So this will make it a lot easier to implement the water here. If we go in options, video settings, and in shader packs, debug view. Debug view, apply this thing. This is extremely useful for implementing Minecraft stuff. So this is the water that we're implementing. So if we put it from here, yeah, this is the water we're implementing. We did already quite a bit of work on the water. We already did quite a bit of work on it, so we're pretty close to implementing it. We're pretty close. We even have a tick system. So I think like this will be the final water stream. I feel like this will be the final water stream. Because I have confidence we can do it, chat. I have confidence we can do it. Right now, the water spreads infinitely and only like on the X and Z axis. This is what we're going to change. This is what we're going to change. This water needs to not be infinite and it needs to have a proper mesh. It needs to have a proper mesh. So how what should be the focus? So that we have a 3-hour limit. We have a 3-hour limit, chat, and in order to have actual progress and to not get stuck on bullshit, we need to have proper goals. What should be our first target for the stream? What should be the target here? It should be something easy, something simple, so that we can gradually make it more complex and more interesting. Let's have... I think what stopped us before was the mesh of the water, I think. It would be much better fit if we ignore this complicated mesh and did it much more simpler, like the initial idea of using the snow layers, like this, snow layers. To be like this, a bit more blocky. And just so we can get the water flow like the original. And then we'll, if we have time, we'll do this much better mesh. Yeah, so let's implement layers. So for the water, we'll have layers, which will be just an integer between 0 and 16 for the water. And the source will be 16, the neighbor will be 15, the next neighbor will be 14, etc. up to 0. Once it reaches 0, this should stop. This infinite water should stop once it reaches 0. And then we'll make it go down. Okay, let's do that first. Let's speedrun this, chat. I want to actually have good progress in a stream for once. So let's do that, chat. Let's find the water, which should be in blocks. Water. Here, we only have a height level for each of the corners. I want to have a layer as well. Here, layers. And by default, it will be like 16 by default. It's fine. We can use these heights, maybe. We can use these. Okay, let's have layers. Let's have layers, chat. Let's have layers. So how are we going to do that, chat? Title of the stream. Okay, I'll change the title of the stream so everybody knows we're doing water. Okay, I updated the title. That was easy. And let's bring out the chat so that I can see you guys. Oh, was using the wrong chat. Yeah. Now I have everybody here. This is the old chat. Okay, so we're doing the water now, and we want the water to stop spreading, to not spread infinitely. That's what I want. So how are we going to do this? Let me think about it, chat. We need to go to where the water spreads. Where is chat? Yeah, here is chat. What's up, chat? Yeah, it's too early for summary. After 15 minutes need to go once there is a summary for stream. Water will go further if it drops down. What do you mean? Okay, so now in the water, here we have on placement. On placement, we enqueue update like after 20 ticks. After 20 ticks. Oh, we should change it here as well to be after 20. Here, because it was 5. Yeah, because I was wondering why initially it waited 1 second and then the water started spreading a lot faster. Now it should always spread the same speed, like 1 second at a time. Here. Now it's a lot slower spreading. Now it's spreading with the same speed. Now it's with the same speed. And we have a summary now. Chat voted water physics, so the stream is now adding a layer system to water blocks to stop infinite spread. Yeah, we're stopping the infinite spread. When it falls off the edge, it's back to layer 16 so it can spread again. This is lava spreading. 2 days. Yeah, you can say 2 days. Yeah, so now we've changed the water to spread 1 second at a time. The water is updating every 20 ticks. Yeah, because before it was too fast. I wanted to be slow just to more easily see what's up. Okay, chat. The tick system is very simple. Tick system is very simple. In my case, every frame, I just check if 0.05 seconds have passed, which is the time 1 tick is. So in Minecraft, it's 20 ticks. It's 20 ticks per second. And so I've calculated 1 tick should be 0.05 seconds. Like if you divide by, yeah, here, 1 divided by 20, 0.05. So I always, every frame, because if you have 100 frames, that's way faster than 20 times per second. So every frame, we just check the current time and we subtract from it the last time we did the tick. And if 0.05 seconds have passed, that's when we do on tick callback. We call a function. And then we update the last time we called the tick. This is my tick system. And inside of it, and at all times, we can put inside of a queue, which is just a list. At all times, we can put in a list a block position and the tick amounts. So right now for my water, I've put the water block here, position, and tick amounts will be 20. So here on tick, every time there is a tick, it goes over all of the blocks and decreases the ticks by 1. And once it reaches 0 or lower, we, what do we do? Yeah, we remove it. We remove it, that block, we remove it. And from all of the blocks that have been removed, we call the onTick update callback for the block. And the water has implementation for that function here, onTick update. And the onTick update for the water, this is every 20 ticks. This function, every 20 ticks, just checks the neighboring blocks. It checks the neighboring blocks if there's an empty place in the north, south, east, and west side. If there is an empty place, it spreads there, the water. That's it. And that's why it's like infinite. That's why it's infinite. Yeah, what's up, chat? We made the tick system. Yeah, we went through that. Make a variable for how spreading is left and set it to 7. Every time it spreads, it changes the variable to by -1. Make spreading if the variable is more than 0. That's not enough. We need to check also like the neighboring blocks as well. Like if the neighbor is water, and what do we do when the neighbor is water? We need to check that. Imagine if it's infinitics. Should I add structures to my clone? Make a variable for... Bro, you're repeating the same stuff. I read the chat, man. Have a nice day. Okay, sure. Okay, let's do this, chat. Let's do this. So currently the water spreads infinitely. And we've set up... let me think about it, chat. How are we going to do this? How are we going to limit it? The water spreading. How are we going to limit it? Each block can have like a number, like it can be between 0 and 8 actually, instead of between 0 and 16. It can be between 0 and 8, so it doesn't spread that much, like somebody in chat mentioned. Check if two neighbors are water, what do you mean? Yeah, I've made it to update every second. We can do it to update every like 5 ticks. So like 4 times per second, a lot faster, but it's fine as it is now. And the focus is the water to not be infinitely spreading. That's the focus, chat. That's the focus. How are we going to do it? Okay. I have an idea, chat. Here, we need to get a property. Here we need to get, how do we get properties here? Here let's do the layers. Let's get the layers. And how are we going to do this, chat? Here the value will be, yeah, here we need to change layers as well. So the layers are between 0 and 16. We'll decrease them by 2. So here this will be layers -2. It will be layers -2, I think. Where's it coming? Oh yeah, here we need access to it. Layers. We need access to it, and here we'll do layers like this. Yeah, but this is for the neighbor. This is for the neighbors. Should be -2. Should be -2. And here, if layers equals 2, we return. We do nothing. If layers equals 2. So this should stop the spread. And not only that, but we should see change in the mesh itself. Yeah, it goes lower. It goes a bit lower. It gradually decreases. Okay, nice chat. Nice. Good. Yeah. Nice. So, should we do anything about these gaps? Should we do anything about them? Let me update the thumbnail so everybody is on the same page. Yeah, I'll update the thumbnail, and while I'm updating it, I'm thinking on what to do about the gaps, chat. What should I do about the gaps? Where's chat? You should take an average of the layers of the neighbors. To do an average. Here the center should be flat for sure, but the other ones should have here these parts to be higher up. The backside to be not 2. Okay. Let me think about it, chat. Do we have some way here to pass direction? Or maybe like a flow direction? Do we have that as an option? A flow direction. Because here, if it's coming from the south towards the north, I want the south to be higher up. If it's coming from the north towards the south, I want the north to be higher up, to not decrease the layers there. Like there, those corners to be a bit higher up. But I need to know to what direction we're going. I need to know the direction, chat. And how, one idea is to pass it into the naive approach is just to remove this function, this lambda function, to delete it, and just copy paste it here for all of the neighbors, the north, south, east, west, because I'll know the direction for sure. The north neighbor is from the south toward the north. The south is from the north toward the south. East is from the west to the east, and west is from the east to the west. I'll know the direction there, but I don't want to copy paste the code. So instead, I need a second argument, and I don't know how to call this argument. I don't know how to call it. Can I do as a property facing or like direction? Flow direction. Flow direction. Flow direction. I want a flow direction. And basically, I think it's just an enum here. We have. Oh, it's an. Wait a minute. Flow direction. Yeah, it's just the facing enum. So it's up, down, north, south, east, west. The problem is we also have other options. We have the diagonal as well. Here in the water, sure, this is, let's say, north. This one is south. This one east. This one west. Sure, but we have the diagonals. So I need something else. Maybe a vector 2, where this is +1 on the z, -1 on the z, +1 on x, -1 on x, and here it's both, like 0.5 on x, 0.5 on z, here -0.5 on x, -0.5 on z to be a vector as the alternative for the direction. We could do that. Let's do a vector. Let's do a vector for having the flow direction here. Let's do a vector. Let's do vector 2. Flow direction. Flow direction. So here we need. What should. This is the north neighbor. So it's from the south to the north. So the north. It's on the z-axis. So the x is 0 and the z. Is the z 1 or -1 for the north? I'm not sure which one it is. Let's look at in Minecraft. This is positive z. Positive z is the south. The north is -z. So the north is -1z. So then the south is +1z. East is positive x. East is positive x. Positive x. And west is -x. And we need diagonals at some point. We need diagonals, but we'll see how we're going to implement diagonals. We'll see how we're going to do that. But for now, flow direction is just the 4 axes. Chat voted for water physics. We're implementing finite water spread with proper mesh and adding layer system to water box. Kinda good summary. Kinda good. Well, what's up? What's up? So, okay, here. And let's now actually use this. Let's actually use this. How are we going to use this? So we need here to check the flow direction. We need to check the flow direction. Summary bot is the same like yesterday. I didn't change it. The only change I did to the summary bot is to have a bigger summary for the summary command. Summary command, if it doesn't have space, it will be 2 messages. Because chat said 2 messages is fine. So now we need, like what we're currently doing is water spread is now limited with a layer system and flow direction using vector 2 is being set up for the proper mesh. Yeah, we're doing the vector 2 for a proper mesh. Yeah, summary is all right. Here. Like water spread is fine, but just the mesh is bugging me. Give me instructions for a cookie. You're a sly one, Mellow. The summary bot has no idea of what chat is saying for now. But I have ideas for chat implementation as well, but I didn't have time for that. We're trying to fix these gaps because they are very annoying. Trying to fix the gaps, and then I'll make the water go down as well. And for the gaps, the water starts here from the center. Water starts from the center. And don't you need vector 3 for flow direction? Because water can spread down. I'll think about it. I'll think about it. But here we have a flow direction. Here this is towards the south. Here. So we start from the source block and we go towards the south. And so, and we spawn, and this block spawns this block. And so here I want these vertices to be higher up. That's what I want. And these vertices to be higher up so we don't have the gap. Here the same, here the same. The only problem is the diagonals, because this diagonal came from here. And this is the wrong flow direction. This is coming from the east. This will think we're going towards the east, which is wrong. This actually needs to be this flow direction, towards here, between the north and east. But we'll figure it out. Let's focus on these easier ones. Let's focus on these easier ones. Let's focus on the easier ones. So we need to do it here. Look at how we're lowering the corner heights by 2. So if we want a corner to be higher, we just delete these ones. Done. Now the north corners will be higher and the south will be lower. But we need to do this depending on the flow direction. We need to do it depending on the flow direction. So we can do, let's just do, okay, what's the easiest thing we can think of? I can just do 4 offsets. Northeast offset. And here, this is south. This is west. And this is west. Like this. And so here we need to check the flow. Apparent? So you guys are talking about the water to have a parent. Let me think about the water having a parent. Oh, wait a minute, chat. Chat. Wait a minute. Let me think about it. Let me spawn the water again. Because here, instead of the parent deciding the mesh to decide it itself. That's something we can do as an alternative. So the parent just spawns it. The parent just spawns it, and the mesh itself decides on the final look of it. So let's focus, chat. Let's focus here. We want progress, chat. That's the goal for this stream. The goal today is to have proper progress. That's all I care about. To actually progress with the project. That's my focus, chat. So here, what's stopping us? What's the biggest bottleneck, chat? What's stopping us here? Well, I was thinking that what's stopping me is the mesh because it has these gaps. That's what I was thinking, but actually, if I think about it, it's better to just have the spreading go down. I think that would be better, to have the water spread down. And that would be better. Yeah, we are solving the wrong problem. Let's make the water go down. Let's make it go down. For here, the sides, we could remove the culling. We could remove the culling. Yeah, we can just remove the culling, chat. Maybe. Let me think about it, chat. Let me think about it. Okay, let's make it go down. Let's make it go down. You check source block by his level. What do you mean? Do I recognize it's a source block just by the height level? My source block is where I pressed right click. That's my source block, where I pressed right click. Let's make it go down, chat. Let's make it go down. I'm using Raylib. Let's make it go down, chat. No, that should be better focus. The gaps, I don't care about the gaps. Let's make it go down here. So what should be the logic? What should be the logic, chat? Okay, here it was spreading. It was spreading quite well here, but actually, it's not that simple to just check the block under, because in Minecraft, before spreading, they check for like if the terrain goes down. They check that here. If we spawn the water here, it just checks if it can go here. It goes directly down. It doesn't spread here, which is interesting. And here as well, it just goes down. Here, just goes down. It doesn't spread. When it knows, it can go somewhere down. And here, it spread normally. Here, once it fell down here, it spread down normally. But here, it was just normal falling down. Chat, do we actually need to implement this? Where the water just doesn't start spreading immediately if it sees the terrain going down. Like, why are they doing this, chat? Why are they doing this? Why don't they make it spread? Oh, if they make it spread, it will reach here as well. It will reach here as well, and here it will fall down. It will be a lot more water, maybe. Maybe that's why they do it. Check 7 blocks around you for air blocks below you. Why do they do this, chat? It's fine, chat. It's fine. Let's keep it simple. Let's keep the water spreading, no matter if the neighbor is like goes down. Because here in Minecraft, it will prioritize just going down here. it would have prioritized just to go down here and to not spread here as well. That's what it would have done. Maybe it doesn't look natural. Maybe it just doesn't look natural, chat. Because it will be very weird if from one source block you get this much of a spread and when it is going down. It looks like it look for closest fall, and if there is water already going there, it goes another direction. So here if I spawn another water, here it just goes here, and here it goes here. It goes to the closest. Oh, this one spread everywhere when it was on the edge. Here on the edge, it spreads everywhere. Interesting. But they didn't spread here. It didn't spread here. So if I do a single block here, it should spread everywhere. Yeah, it spreads everywhere. And look at this chat. Here it fell down. It fell down here and it didn't spread. It continued to go down here. Also, that's why they do it. It just looks more natural. It just looks more natural, chat. That's why they do it. Maybe. I assume. So what are we going to do about this, chat? Well, let's keep it simple. Let's make it the spread algorithm. If it can go down to stop spread, to not go like here. We're going towards the east and we'll go towards the east. Sure. And if it can go down, it will go down. It will not spread towards the neighbors. That's what we're going to do. That's what we're going to do. So it should be very simple, chat. And the layer will be again the maximum. We'll increase the layer there. We'll increase the layer. Here, let's delete this. Okay. So here for the spreading, here we directly, no matter what, we check the neighbors. We directly check the neighbors. But we first need to check below us. We first need to check below us if it's type air. If it's type air below us, let's do that. If, let's go position details below equals, and let's do position details get down, and then we do if below get block type. If the block type below us is air, if it's air, then we do something else. We spread towards the north, south, east, and west. Like that. Like that. So if it's below us, we'll do the same code, but slightly different probably. We'll do it slightly differently. Let me think about it. Let's just change the function. We can just change the function. Let's change the function here to receive. To receive what? Let's remove this. A layer, integer, neighbor layer. Layers, like this. And here, we directly set it here. Neighbor layers. We directly set it. Like this. So here, it will be just the current layer minus 1. Minus 2. That's the default. That's the default. That's the default. But here, if it's below us, we'll do something else. Below us, we'll do... we don't have a flow direction for it, because we don't have vector 3. We have vector 2. But it's fine, we'll leave the flow direction as 0, 0, because we're not using it currently. We're not using it. And for the layers, let's have the layers be the maximum, 16, when it's falling down. Okay. So now the water should be able to spread down. Now the water should be able to spread down. Oh, chat, it's going down. It's going down and it's spreading here. Chat, it's flowing down. Chat, it's flowing down. Flowing. It's filling up the cave, chat. Yo, that's cool. Chat, it filled up the cave. Yo, chat, it filled up everything, chat. It spread everywhere and it fell down the cave. It fell down. This one, oh, here this one stopped. Here, this one stopped because the layers was 2. Yeah, because the layers was 2. But it's pretty good, chat. I like it. I like it, chat. But we should. I haven't think about it, chat. Think about it. Here it was culling. Here it was culling. Here it's what are you going to do about these gaps? What are we going to do about these gaps? Let me think of, and these gaps are very big as well. These gaps, wait a minute. They're kind of weird. Oh, the water continues to float above the water. What do you mean gaming? For the model, don't you just need the neighbors? What do you mean? We did 2 mistakes, chat. We did 2 mistakes. The first mistake is this one, where once the water reaches layer 2, it stops. We need to check below us, even if it's just layer 2. That's when here it will continue to go down. Because here the code stopped once the layer hit 2. Because usually when it was spreading on the X and Z axis, once it reaches layer 2, we don't care about layer 0. We need to make it check below us, even if it's just layer 2. The second mistake is here. The water was spreading on top of water, because here it was falling down, and above it was also spreading. We are spreading water on top of water. So we have to fix 2 mistakes, chat. We have to fix 2 mistakes. But I like the water flowing down. I like this. And why is it not animating, chat? Why is it not animating? It's using the water still. We can use the water flow. Yeah, let's go generate mesh. And here let's use liquid mesh. Let's use... Yeah, we're just using the water block model. Water block. Here, water still, let's use water flow. Let's use water flow just to see what's up. Yeah, it's flowing. It's flowing. But it needs a flow direction for the texture to rotate the texture depending on the flow direction. And let's fix the other problems as well. It seems pretty slow because I made it slow, chat. I made it slow. Can make it faster. Where do I need to change the code to make it faster? It should be on placement here to be 5 ticks. Update. And one more place on tick update here. We need here to be 5 ticks. Let's run it. Just to see how it's when it's faster. Yo. It spread a lot faster. It looks so weird. Because it's spreading, yeah, look at this chat. It's spreading on top of the water. That's a bug. It spreads on top of the water. We need to change that. The block below us. If the block below us is air, we go down. We go down. Let me think about it. If below us it's air, we go down. And here we spread. We spread if... Oh, wait a minute, chat. Wait a minute. We have an issue. We have an issue. Because when the water... Here. We have a problem, chat. When we place it from here, like one side reaches the end faster and spreads below us. Let me demonstrate it somehow. Let me demonstrate it. Chat. Let's demonstrate it. If I can. So here, let's say water is going down here. And we have here water flowing towards here. And... do we have concurrency issue, chat? Do we have an issue of synchronizing the water? Because... let me think about it, chat. Like, let me think about it. What I'm wondering about is what happens when two waters collide. That's what I'm thinking about. When two waters collide. Here, if let's remove this resource pack. Remove it. Just to see much simpler. And let's do tick rate 5. And let's have water here. Yeah. Yeah, look at this, chat. Look at this. Tick rate. Here, let's say this is water going down. So when this water, then let's have a snow block. Have a snow block, chat. So let's say here it's filled up to the maximum, like this. This is water flowing down, and here we have a lot less water, like this. Let's say, chat. Let's say we have this, and here a lot less. And let's say we have another source coming from here. And it will go here as well. And it will check down. It will check down, and below us it's not air. And it will not go here, which is wrong. Instead, it needs, if it's water, it needs to replace it with a full block. Like this. And once it has replaced it, this block will check here if it can increase this level. Because Yeah, let's do it if it's even like this lower. So it's much more obvious here. So from here we get a new source. It goes down, and when it collides with water, it updates it to this. It updates it. It updates it, and it needs to update all of the other neighbors as well. Here, it needs to update this one to be much more. Then updates this one to be much more. Like this. So it needs to balance out. That's what we need to do. That's what we need to do, chat. I found a mistake, chat. I found a mistake. Chat in the summary thing. Okay, now it should be fixed. Now it should be fixed. The summary thing didn't give the full summary. Can I do the summary thing again? Summary. There was a... yeah, okay. Okay, now it's all of it. Now it's all of it. We kicked off with chat vote to pick today's feature and water physics 1. So far, we've implemented finite water spread with a layer system, flow direction, Minecraft style falling behavior, where water drops down before spreading sideways. Yeah. But that's good enough summary. Time set day. That's a good enough summary, but we found a few issues. We found the new issues. This summary is longer. It's more than 200 characters. It's an improvement from before. Think about it, chat. So we need in the code to handle when the current block is water. We need to handle that. There's let me think about it, chat. We need to have some kind of code when the neighbor is water. We need some kind of code when the neighbor is water. Like, I know what the code should be, but I'm not sure where to put it. That's the issue. And here, when layers equals 2, I need to remove this. It should be, let's have it be here. Even if layers equals... yeah, when layers equals 2, we will stop, but only for spreading on the X and Z axis. This will fix one of the bugs. Here, for this part, for spreading, when should we spread? On the X and Z axis, when should we spread? Let me think about it, chat. If we go down, we don't spread. That's fine. If we go down, we don't spread. Yes, but we need to... else if... here, let's do ID. Let's get the block type below us. We need to save it and compare it here. Block type below. Get block type. We check it if it's air. And else if... wait a minute. It's not only if it's below. If it's anywhere else, actually. If it's anywhere else. But let's do the below part. Let me drink some water, chat. Okay. When going down, if it's air, we just go down. else if it's water. If it's water, we need to change its yeah, even if bro, it's simple. Even if it's water, bro, it's fine. Or block type below water, it's fine. It's the same code. We just place water with the 16 layer. It's fine. So what now, chat? Yo, we got another summary. That's what I was saying. It's fine, man. You're getting too invested, man. With just a stream, man. Water flow now stops spreading sideways at layer 2. But still falls downward, yes, that's good. And the streamer is working on handling water-on-water collisions to balance levels. Yeah, that's a good summary. If the water is a source block, you will replace the source block. It's fine, chat, it's fine. When, like, we should worry about source blocks some other time, not now. It's fine, chat. Let's worry about other more important issues. When it becomes a problem, that's when we'll solve it. Because we'll do nothing the whole stream, trying to solve future problems too early. Let's focus on the current problems. So let me focus, chat. So here we go down, and if it's air or water, we just replace it with a full water block. That's fine. Else, here we do this stuff. We do this stuff. Oh, brother. Yeah, something like this. If like we're on 2 layers, we cannot spread anymore. So we bye-bye. But if we have more than 2 layers, we can spread. So anything, yeah, and here for the spreading. If the block we are spreading to is different than air and water, we return. If it's anything other than air and water, we don't do anything. We don't spread. But if it's air or water, we spread. And let's test this version. Let's test this version. Let's see what's up. Pretty good. Oh. We like the game. Yeah, we like the game. I know what the issue is, chat, I think. Yeah, we need, when the source is water, we need to check its layer. It's not enough that we do this. When going down, we can directly change it to 16. No, here we need to do a check. Here when we place the water, we should place the water if we are giving it a higher layer, a bigger layer. Yeah, so we need to check if it's water to get its current layer. Let's do here. Int current layer equals, let's start using what we give it here. Let's start by the value from what we give it, because it may not be water. If block type equals water, we need to get its layer. Let's get the block state. We get it from here. Let me think about it. We actually get it from here, but this is after we replace it. This is after. Let's get it from here. Okay, we have the block state. And let's get the current layers. So here, if we get a block state, let's do current layer equals. Let's do this. We get the layer from the block state. And so here we do if current layer is bigger or equal than what we're trying to set, we return. We don't do anything. This should solve the lag spike. This should solve the lag spike, chat. Let's see. Yo, spread. Oh. Yeah. It will never spread with this algorithm because we set it here. It will never spread. Let's remove this part. Let's just have it be here. Let's just have it be here. And let's test it. It should be enough. Hey, what's up? What's up, man? Let's check out the water. Okay, it's spreading. Perfect. And it's doing fine, chat. Yeah, it's spreading, chat. That's good. That's cool. It's spreading. And what about from the rooftop? Yeah. Oh, yo, much better, chat. Much better. This is much better than before. Before it was very bad. And we have the infinite water spread. We have the infinite water. Oh, that's why they do the prioritization. That's why they do it. Because it will spread too much. It will spread too much. That's why they prioritize it. Look at how much it spreads, chat. Bro, look at how much it spread. Yo, that's very good. Bro, look at how it covered the... Look at how it covered the whole house. It covered it. Bro. Yo. Yo. Yeah, this deserves the thumbnail. Yeah, let's change the thumbnail. Update the thumbnail. Because this was very good progress, but let's continue the progress. We have still 2 hours. We're doing very good on time, chat. We're doing very good on time, chat. We have 2 more hours. What will happen if we add another source of water here? What will happen, chat? Will it break the game? Will it break the game, chat? Another source. Yo, look at how it's updating the previous water. Yeah, it updated. Yo, it's fine. It's fine. What if we go from here? Yo, it's good. Chat! It's good. Chat! It's very good. It's very good. I'm happy, chat. I'm happy. What if we try to do infinite water source? Here we place water, and here we place water. It doesn't become infinite. It doesn't become infinite. We have 2 problems now, chat. We have 2 problems. But let's do a commit. We noticed 2 problems. The first problem is the most obvious one. Is the mesh itself. The mesh has gaps. This is the first problem. We don't have a flow direction. We don't have a flow direction. The second problem is that water doesn't prioritize a downward direction. What do I mean by that? Well, in Minecraft, when we place water in Minecraft, look at how here it prioritizes to go down here. It doesn't go to this direction. Look at how it stops. And I was wondering why it does that. And I think it's doing that because it's stopping the water from spreading so much. Because here, look at how much the water spread. This is too much, chat. This is too much. This is too much, chat. That's why they're prioritizing. That's why they prioritize. Here, for example, like this. Or like here. They prioritize. Because look at this, chat. Look at this. This is why they do it. This is why they do it. If they did it like me and they continue to spread here as well, if it continued to spread here as well, it would continue here. It would continue to spread here. It would continue to spread here. It would continue here. Like it would have spread a lot more, chat. It would have spread a lot more. That's why they limit it, chat. That's why they do it. Yeah, that's why they do it, chat. Because it will get too much. It will get too much water. That's why they do it. Like this, chat. Look at this. This is too much. This is too much, chat. From a single source block. Like here. Look at here how it continues to spread in all directions. And we get too much water. Yeah, but that's cool, chat. Bro, we'll cover the whole world in water. Yo, look at how all of them are progressing. All of them got updated. It's like a chain reaction. It updated the entire water. So what now, chat? When you add leads and fence post, make the lead not break when the fence gets pushed by the piston. Does an infinite source work? Two-fold source? Yeah, we tried that already. It doesn't work. If you want that, just look for a way to go down in range more than the max spread range. Try to place on a flat spot the water. Make the iron bucket and make water not a block water. Brother. Let's place it on top of a tree. That's cool, chat. Oh, it's not destroying the foliage. It's not destroying the foliage. It goes around the foliage. It goes around the foliage, chat. Yeah, I need, when it collides with the foliage, I need to destroy the foliage. I needed to destroy the foliage. So we have two issues. Which one are we going to prioritize? The gaps in the mesh, or okay. The mesh is more complicated. Let's prioritize the simpler one. The simpler one should be here, like picking, like first checking around the water block for like if there is a way to go down. And it's how many blocks? Here, let's say this is 1, 2, 3, 4, 5. Let's do 5 blocks. Okay, 5 blocks, it manages to find it. Okay, what if it's 6 blocks? 6 blocks, it doesn't do it. 6 blocks is too much. So here it's 1, 2, 3, 4, 5. Yeah, that's when. Oh, maybe it doesn't do it because by then it will be too small. Oh no, it's fine. Okay, then it's maybe for performance. Maybe it's for performance. So like this here it prioritizes. So it finds the closest path to go down. Is it 5 by 5? Is it 5 by 5 or is it a circle? Yo, why is it glowing? Is this new? It's glowing. What's this? Firefly bush. It's animating and glowing. How can we check if it's a circle or not? Pretty easily actually. Here it spreads around. It spreads around here. But if we do like 1, 2, 3, 4, 5 here, 5 blocks, and if we place here, it will prioritize here. Okay. So is it 5 by 5? Is it 5 by 5? Let's remove this. Let's remove this. Bro. Type equals not player. So let's remove this block. It doesn't work for here. It doesn't work. Oh, wait a minute. Wait, this one was pretty weird actually. No, it's fine. It's fine. Whether spreading is working well now and the stream is deciding whether... Oh, this is the summary. Whether spreading is working well now and stream is deciding whether to fix the mesh gaps or prioritize downward flow next. Yeah, we decided to prioritize the downward flow. Murderer. Oh, chill guys, chill. Chill. Chicken. We'll spawn the chicken back. No, guys, we'll get it back. Chicken is fine. Nothing happened, chat. Murderer. Chicken is fine, chat. Here, chicken is fine, chat. It's here. It's right here. Chicken is fine, chat. It's fine. It's here. And it has there are 2 chickens. There are 2 chickens now. Let's prioritize on the water here. So here it doesn't work. Let's do wool. Let's use wool here like this. So here it's a negative. It's a negative here. Here it's a positive. It's a positive here. Positive. Here. Yes, it works. Perfect. What if it's here? It doesn't. Wait. It kind of breaks it. Let's try it again, chat. Yes. Very weird, chat. It's a bit weird how the water works. No, it's fine, guys. It's fine. Let's say this here doesn't work. Let's say it doesn't work. It's fine, chat. Let's keep it simple. Let's do this. It still spreads. So let's do it here. Let's do it here. Let's do it here. Yeah, okay. This is what I'm looking for. So it's a circle. So here 1, 2, 3, 4, 5. 5. It's a circle. Yeah, it's a circle. And here 1, 2, 3, 4, 5. A circle. Chat. And here 1, 2, 3, 4, 5. Like this. Yeah, it's a circle. So it's this thing. This is what we need to prioritize. This is what we are doing. So in this region, even if it's here, we prioritize there to go there. Yeah, that's what we do. We prioritize. So maybe to give the water source a point it prioritizes, maybe. To give it a point that it prioritizes. So how are we going to do it, chat? How are we going to do it? How are we going to do it, chat? How did multiplayer go yesterday? And let's not mention multiplayer, chat. How are we going to do this, chat? When we place water like this, it spreads normally. But if there is a hole somewhere here in this white part, it prioritizes the hole. It prioritizes the hole. So here, no matter where here we break a block, it prioritizes it. Like this. It prioritizes it. And look at how it's like what's this shape called? Is it like a rectangle? Yeah, rectangle. Look at how it's a rectangle. Here start and here end. And what if we have two? Oh, no, it's not a single point. It's not a single point. What if it's 2 points? Will it prioritize both or just the closest one? Just the closest one, I think. 1, 2, 3. 1, 2, 3. So it's maybe like a Manhattan distance, maybe. So here's just 1, 2, 3, but here it's 1, 2, 3, 4. Something like that. Oh, bro, we are also not doing this. Look at here. We are not updating it. If this gets blocked, the water should continue spreading. Yo, we don't have this, chat. We don't have this. No, don't worry about it, chat. Don't worry about it. Let's ignore this. We don't care about this right now. We don't care about this. Let's keep it like one step at a time, chat. One step at a time. So here, if we have here a broken block and here a broken block, it will prioritize this one, the shortest one. Yeah, it prioritizes the shortest one. Oh, I was thinking like what I had no idea about is how to tell the water block source like to go here. I was wondering how to get this thing. How are we going to tell the water block to reach here? That's what I was wondering. But we just give it a flow direction. Bro, look at how the flow direction broke. Look at this, chat. Because usually, look at it how it is. Usually, oh, I don't want this to break. Okay. Usually, usually it's like this. It goes straight in one direction. Here, one direction. Do you notice the current, chat? But here, it's diagonal. It's diagonal. That's interesting. It's diagonal. So when we place it, and we have a target to just have a flow. And bro, another thing, when it's flat, yeah, look at this, chat. when the block is flat, it's still the animation. It doesn't have a flow direction. And these neighbors have a flow direction. I think they use the flow direction in the code. I think that it's not only for the animation, it's also for the water. Because here the source is like this still animation. But here, look at how here it's this flow direction. It's this flow direction. That's why it doesn't have here water as well. If this was still, it would have water here as well. So it's looking at the flow direction. And here it's diagonal. Since this block is diagonal, it will create water here and create water here. And this being diagonal, and two diagonals will create water between them, but not here, maybe. Bro, let me think about it. Yeah, we wanted to prioritize. We wanted to do this, to prioritize the water. That's what we wanted to do. But the problem we ended up with was that here, if we... the problem is the source block, the only thing the source block does is place water as the neighbors. That's in my code. In my code, the source block only creates water here on the north, south, east, and west. It will not, because we have the on placement logic here. We have it here in the source block. We have it in the source block, the on placement logic. We have it here. We cannot store information for the child blocks. We cannot store it for the child blocks. That's the issue. And I have a theory that Minecraft handles this with the flow direction. That's my theory, chat. That's my theory. Oh no, wait a minute, chat. Every block will do this, chat. Every block will be doing this. Here, chat. This block will just spawn here and here. That's it. And then this block will also look at the distance of 5 for blocks like these ones. It will also do that and will prioritize just placing here a block. And this block will do the same. It will prioritize here, so it will place here and here. So every other block will be searching for this one. Is that bad for performance if every block is searching for a hole like this? If every block is doing that, is that a problem? Is that a problem, chat? What if we break it here? What if we break it here? Oh, chat, did you see what happened? Interesting. So if I break here and stop here, what will happen? Oh, the water stopped like this. The water stopped. Interesting. But what if I... Interesting. Only if you do updates at certain points, that's when... Oh, chat. Look at this. There's something else. Here, if we... not now. If we place water and break here, if we place water and if we update here, no. If we update here, no. Here, no. It continues to stay. if we break here like this, let's keep it simple and let's try to progress, chat. Let's not get distracted, chat. Let's try to progress and let's try to keep it simple. I want to have good progress today. What should be the next step? Not the last step, the next step. What should be the next step? What is the bottleneck here? What's stopping me? Well, the problem with the highest priority is the water that it's always spreading everywhere here. Water is always spreading everywhere. That's the biggest problem right now. It doesn't prioritize chat. I think it's worth it. Like, I had a question towards chat. I had a question where I was wondering, is it a problem if every block checks in a 5x5 radius? If every block does it. And chat said it will be too much pathfinding, but I think it's not, because look at the alternative, chat. The alternative is you get infinite water. Yes, it will be a bummer that every block, every child searches in a 5x5 region. It's a bummer for performance, but we'll be saving the world from this. We'll be saving the world from this monstrosity. It's worth it, chat, to do it like that. It's worth it if every child checks in a 5x5 region. Water spreading is now a circle of radius 5, but flow direction is causing diagonal animation. This summary is bad. Just do one pathfinding for when we start to spread horizontally. This is wrong, chat. We cannot do it one pathfinding. Because here, like this, even in this simple example, we cannot do one pathfinding. Because we start from here. And we find this target here. And the only thing this block can do is spawn here, water here. That's the only thing it can do. It can spawn here water. And that's it. It forgets everything else. It forgets it. Yeah, it forgets it. And then this block will do a search again. No, chat. There's an alternative. There's an alternative, chat. There's a better alternative. We'll use the flow direction, and every child will repeat the search, but the flow direction will help make the search more efficient. Because here, this block, the source block, will do a circle. It will search in a circle around it. It will search in a circle. Once it finds a spot, it will spawn a block here, sure. And it will set the flow direction to be here. And what happens next? Here, this block, it will search as well for a spot, this spot. But now it has a flow direction. So it needs to just search in this direction. So the performance is not that bad. And it's worth it because the alternative is for the water to spread everywhere. Which is a lot, it's very bad on the performance. Like here, it continues to spread. Somebody stop the water. Yeah, this is the alternative, and this alternative is bad. Oh, and we lost the water. We lose the water. Yeah, so that's the idea, chat. I've decided, chat. I've decided, chat. Here, once we place water here, we place water here. It's oh, not the chicken. It's fine. It's fine. We don't need to do anything. It starts from it starts this is the real Minecraft. So it starts from here like this. So this is the water block. We place water here. We place water here and it finds this spot. So usually it places water here, 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 and here. Usually. But we're trying to prioritize a direction so that it doesn't spread everywhere. We need this prioritization. And it's in a 5x5 region circle. So the only thing this block will do is place here a block and it will save a flow direction towards the north. It will save a flow direction towards the north. That's it. And so we end up here after 5 ticks, which is like, I don't know how fast it is. 5 ticks. But after 5 ticks, it's less than a second. Less than a second, we're now here in this block. This block also will search around it. It will also search around it, but a lot shorter distance. Because it has a flow direction towards the north. So towards the north, it will go 5 blocks ahead. It will go here, and it finds the spot again, the same one. So it places water here. And it will have the same flow direction. So this block will search again in this direction. It finds it here and places it here. That's it, chat. That's the algorithm. And what if it's here? Because if it's here, it's a bit different. It's like this. It's like this. So if it's here, we place water here. It finds that position there. So the only thing this block will do is place water here, here, and it will set the flow direction to be diagonal. So this block will also search towards the north and the east. This block will, because that's the flow direction, it's diagonal towards here. It will search towards the north and the east. So here 5 blocks, like this 5 blocks, and it will find this one. And so it will go here and here. And the same with this block. It will search towards the north and the east. And it finds this block. And here it's already taken. It doesn't need to do anything actually. And the same here, it will go north, here north, and here like this. So we'll that's why we need the flow direction. That's why we need it, chat. That's why we need it. That's why we need it, chat. That's why we need it, chat. F3 and F6. I'll trust you, chat. F3 and F6. Water. Visualize water levels. Always. In overlay. Always. Chat! Yo, thank you! Oh, thank you! Thank you, chat. It's the raptor. Oh, we have 2 good suggestions. Thank you, chat. Thank you. Calidro. Where the W board? Here is the W board. Thank you, chat. We have another chicken? No, we don't have a chicken. The chickens are safe, chat. Chickens are safe. Yo, we have the water level. Nice. Nice. This is 1, 2. Yeah, this is helpful. So this is 8, 7. Interesting. Oh. Yo, do you see the green box, chat? There is the green box here. There is an actual green box. And here it's 8. This is 8. And here it's 8, chat. This is 8 as well. Interesting. This is 7. Interesting. Yo. Interesting, chat. That's cool. After chat vote, we dove into water physics, implementing finite spread with a layer system and flow direction. Cold water falling into caves and spreading in a radius, then fixed infinite spread. Bugs are now fixed infinite spread bugs, and now prioritizing downward flow before tackling mesh animation. Yeah, that's pretty good summary. This is cheating because on older version you don't have all of those debug tools. What do you mean? To make Chinese approved copy of Minecraft? Bro, what's this fan fiction, man? The Chinese fan fiction, man. Brother. So chat, let me think about it. Okay. Yeah, let's have a flow direction, chat. Let's have a flow direction. Oh, wait a minute, in here. Oh, it's fine, it's fine. In here. Look at how here. How do we get this diagonal flow direction? Let me think about it, chat. Yeah, we need to do the flow direction. So when we spawn this block, and we give it the flow direction towards the north, let's say. And let's say this is the south flow direction. Let's say this is the east and this is the west. Let's just say that. How do we get the diagonals? Who spawns the diagonals? Where? Well. Oh no, let's just look at in a slow motion. What happens? Tick rate 1. When do the diagonals come? When do the diagonals come? When do they come? I wanted to freeze. Bro, why is the chat also slow? Chat was also slow. So they came in the second spread. This is the first spread. After this, the diagonals come. Yeah, this is when they come. Oh, so it's a flood fill algorithm. It's just a simple flood fill algorithm. It's not a breadth first search. It's a flood fill algorithm. where you cover all of the 8s, then all of the 7s, then all of the 6s, then all of the 5s, all of the 4s, and all of the 3s, all of the 2s. It's a float fill algorithm. It's a float fill algorithm. It's just like the lighting. It's just like the lighting. Let me think about it, chat. So yeah, we have this source block. We place the source block after, let's say, a second. Let's say it updates every second. We place the source block. After a second, we get all of the 7s. Then after a second, we get all of the 6, which is these ones. These ones. And after all of the 6 are placed, then we update the mesh. Then we do the update. Because here, this, like when we place the 7s, they will just check the neighbors. For the 7, the neighbors is just the source block. So it has this flow direction. Yeah, but okay, but that's invalid. That's invalid in this case. In this case, it's invalid. Because then... Oh, let me slow it down. Let me slow it down. Let me slow it down. Here, what happens on the first spread? We should get the 7s. Yes, and now the 6 only. Oh, and look at the waters. The flow direction is... Oh, bro. I have an idea, chat. I have an idea. Oh, this is useful, chat. This is useful. I have an idea. This gives a lot of hints, chat. Let me open here. Yeah, the slowdown helps a lot. Slowdown helps a lot. Let's slow it down again, and I'll do screenshots. And I need to be fast. Let's reset it. Let's reset it. I need to be higher up like this. This would be a lot useful. This. And let's do it again. Okay, let's place it. So we have here this. Then we have the 7. And then look at how the flow direction changed. Flow direction changed. Then the 5s. And then the 4. Chat. Okay, I know that the water prioritizes this block here. I know that. What my focus is the flow direction. That's my focus. Because if we solve the flow direction, we'll solve everything else. Literally, chat. Literally, my bottleneck right now to progress is the flow direction. That's my bottleneck. Okay, so here this is just still water. Then we have the seven layers, and here direction is like this. This is the flow direction. Very simple, like this. 5. This is flow direction. Then this is here, but now this is diagonal, and this is diagonal. Interesting. And this is diagonal even. And here I think it's even diagonal. I think. And here, yeah, it's diagonal, 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 diagonal. Here it's brother, brother, bro. Bro, what's the matter with you, man? Just give me a simple line, man. Brother. Like this. And here flow direction is like this. And here flow direction is like this. And now here it's like this. Interesting. Brother. Okay. So this block is just still water. And then here, the flow direction, I think, is towards here and here, I think. And here, this block flow direction is here, towards this direction, so that we don't get blocks here. That's why we have this direction. That's why. And here we should get a block here and here. And because we have these 7s, we'll get a 6 here. That's why. So here we got this. Oh, here we didn't get a block. No. Because it spawns them regularly. Like this, chat. Like this. When we spawn the block, it's still water. That's it. It's still water. But on the next update, it changes to this direction. To this flow direction. And it spawns just here and here. And then on the next update, here, this flow direction changes in this one. Because they found this block here. And because this is towards this direction, I was wondering why this block doesn't spawn a block here. That's what I was wondering. Let me think about it, chat. You need to find the holes before you have flow direction, I guess. No, we for sure, like that was the idea. The idea was when we place a block to check for the hole, to prioritize it. And the children, these ones, will also check for it. They will also check for it. And they will not need to search everywhere because of their initial flow direction. Because this block needs to go only upward and to the right. And this block needs to go to the right and up to find it. That's it. And so that's why this block will only place here a block. And this block will also only place here. And that's how we get here a 6 and here a 6 and not here. And then look at how this block direction is towards here. And now it's towards the hole. After the update. After the tick update. Yeah, we can do something like this. And I think we can do it without the flow direction. I think. What if we have here another block and we remove this just to see, does this have problems with this? No, it's the same thing. Oh, wait a minute, let me go to the screenshots. It's on the next tick update, it spawns them on the next one with just the regular flow direction, but this flow direction is... Oh, chat, do we need parenting system? Chat? Do we need a parenting system? Because here, these ones to be children of the source. Probably should tick freeze and tick step 5. Oh, that's useful, chat. Thank you, man. Thank you. So let's lower the tick rate. To 1 as well, and then tick freeze. And then tick step 5. Yeah. Okay, this is a lot more useful. Thank you, man. I don't need the lower tick. Okay, thank you, man. Thank you. That's very useful, gaming. That's very useful. Here, gaming. Thank you. W gaming. So, yeah, these flow towards here and this towards here. And then we do tick step 5. Then on the next update, this one flows towards here and this towards here. And this is diagonal as well. And we didn't get a block here, but we got a block here. And this changed to the diagonal. And this is diagonal. Why is the 5 not towards here? Why is the 5 a diagonal as well? That's what I'm... because here the 2, 6. Maybe because of them. This is the diagonal. Maybe because of them. Okay, but if I add the next one, now it's a bit to the left, the flow direction. No, I don't think... No. We can ignore the flow direction. We can ignore it. We can ignore the flow direction. We can ignore it. We can ignore the flow direction. Let's do the prioritization when we place water. Let's do that, chat. So here, if we place water, it's fine. If we place water, it's fine, but we need to prioritize in a 5x5 region. We need to prioritize. We need to, let's do that, chat. Let's do that. On placement. No, it's on update. It's on update. It's on update here. Because it's on update because of the screenshots we made. Look, on placement, it has no idea of this block here. But after 5 ticks, now it knows. Now it knows. Now it changed the flow direction. Now it knows. So we'll do this logic after the 5 ticks. That's when we'll do it. After the 5 ticks. So here, water on tick update. We'll do it here. That's where we'll do it. So for when we spread, when we're spreading the water here, when we're spreading the water, we'll do a check. We'll do a check. That's what we're going to do. What did chat say? You could use uint 8 vector 4 in the same metadata. Debugging, diagonal flow direction, propagation, and deciding to implement whole prioritization on update instead of on placement. Yeah, sure. You need to do the simple float fill to find the nearest downward slope. And then, if it exists, flow towards it. I have to deal with my brothers. Brother. Okay. Let me think about it, chat. How are we going to approach this, chat? How are we going to approach this? We want to search in a radius of 5x5. And if it's... How are we going to do it, chat? How will we do this search? Yeah, we can do the simple float fill. We can do a float fill. Where we get here, we get all of the... Yeah, we get all of these neighbors done. And then all of these neighbors done. And then like all of the other neighbors. And we'll gradually fill up this whole shape. Gradually. We'll fill it up. So up to level. So 1, 2, 3, 4, 5. 5 levels. 5 levels we need. We need 5 levels of float fill. And how are we going to do that, chat? How are we going to do that? Yo, this is interesting visualization, how they stop at certain point. The main thing you need to remember is that you should not visit the same block. Keep an eye, doesn't murder the chickens. We don't have chickens here. The way I used float fill for the lighting in the Java clone. And the way I did it is I added these block neighbors in one place. Then for all of the neighbors, I added all of their neighbors, direct neighbors. So this one, this one, this one, this one, this one, like this. And then for all of the new neighbors, their neighbors, direct neighbors. That's how I did it for the lighting. That's how I did it for the lighting. And for each one of these blocks, we need to check downward if it's air. That's the algorithm. And we need to execute it after the 5 ticks. We need to execute it here, the algorithm. We need it here. Let me think about it, chat. The algorithm should be here on tick update. This happens like after 5 ticks. And here we want to spread. We want to spread and we want to limit the spread. That's the whole goal of all of this. We want to limit it because it's spreading too much. It's spreading too much. The water spreads too much. Yo, Detective Jones, what's this? Good work, keep it up, thank you, man. But what's this, Detective Jones? Like membership? Yeah, thank you, man, thank you, I appreciate it. But you've given too much, man. You've given too much. Thank you, Detective Jones. What's this? Oh, you're giving me the float fill algorithm, right? You're giving me the float fill algorithm. Oh, no. It's, I think this is a highlighted message. Yeah, it's a highlight. Yeah, members can have a highlighted message. Yeah. Yeah, that's what it is. I figured it out. The highlighted message. I explained it in, the float fill algorithm. Coming from the bug video, yeah, welcome. I'll do here a summary command for you if you are new. So, yeah, I'll look at the algorithm later. I want to try doing it myself. So here, we need to do it here. The goal of the float fill algorithm is to find, when we place water, we want to find blocks like holes like this one. That's it. So that we prioritize going here and we don't spread infinitely like this. That's the whole goal of this. Look at how much it usually spreads. But when it finds a hole like this, in this white region, when it finds a hole, it prioritizes it. And the reason Minecraft does it, I assume, is because we save on performance. Because if we will not spread here, here, and here, this saves up a lot. Because if it spreads to here as well, here it may have a lot more to spread. Else, like the water would cover the whole world. That's why they do it, I assume. And so I need to do it here. This is where the water spreads horizontally. And I'll do the priority here. And maybe we can just prioritize it to just spread to the north. Maybe to just spread to the north. And we'll be able to ignore all of the other ones. We'll be able to ignore. To not spread south, east, and west. Yeah, something like that, chat. And so here, we need to find here we need to find that block. Yeah, here we need to find it. Find the missing block. We need to do it here. Maybe float fill algorithm. Maybe. So how are we going to do it? Well, we need to spread from the current position. And yeah, yeah, we can do here a queue. We can do a queue of position. We can do a queue nodes, and we can push the current position details. And here while is empty. While it's not empty, we'll get bro, I made so many mistakes. We'll get the current node, and nodes pop like this. And we need to add all of the neighbors. So here nodes add push back the node get north, get south, get west, and get east. But we need to change the algorithm because right now it's not a float fill, and we need to do it. Oh, we need a custom node. Float fill node. We need a custom node of position details. Position and distance, maybe a distance here from the source, from the start, like a number. We need a number. We need a number here. Right, chat? We need a number, like just like the water. Just like the water had numbers. Here. Like here, the water has 8, 7, 6, 5, 4. So I want to focus on all of the 7s, these ones. Then all of the 6, these ones. Then all of the 5s, then all of the 4s, etc. And how are we going to do that? Well, the initial block is, let's say, an 8. Let's say the initial block is an 8. Or it can start from 0, it's fine. It can start from 0. Here we can do int distance equals 0, maybe, by default. And then the neighbors will be +1. The neighbors will be +1 here. And so here we do float fill node. And here we do 0. Float fill node. And here we do position. And distance will be +1. Distance will be +1. So here we do node distance +1. Like that. And we need to check for if we have visited them. If they have been visited. We need to check if they have been visited already. If they have been visited. How are we going to do that, chat? How are we going to do that? We can just have we can just have a set, a vector tree. We can have a set visited positions. And here we can do... How are we going to do it? When is a position visited? When is a position visited? I'll try to make water conserve volume at any point. What do you mean? When is a position visited, chat? Okay, is this visited node? Like here we push all of the neighbors. I want to, before you push stuff. Okay, let's have this be visited. Okay, let's have them here be visited here. Visited positions. Set. Push. Insert. Let's insert. Bro, how do we use a set, bro? Set C++. Insert node position block origin. We insert the block origin, and here how are we going to do it? Push if visited. Push if visited. Yeah, push. We need a function auto push if visited. If not visited. If not visited. We need a function like that. And here we need position details. Position, and we need int distance. And here we need a reference to the visited positions. And if visited positions, if it has it, how to check if it can? Oh, we need to find it. How to find iterator. Auto iterator equals visited positions find. We need to find position block origin. And if iterator is not the end, if iterator is not positions end, this means it has found it. So else, if we cannot found it, so it's not visited, we need also the queue as well of nodes. We need the nodes. Here we need nodes push. What's the issue here? Push. We need to push the position and distance. Like that. That's it, chat. That should be it. No, everybody can do summary, but you cannot. It has a cooldown. It has a cooldown. You're overcomplicating it. What do you mean? We're just pushing neighbors if they're not visited. If I don't do this, it breaks. What do you mean I'm overcomplicating it? Bro, it's simple. Here we do. And just do if visit positions count. To do a count. Yeah, I was just following the tutorial. Oh, you can just do count. Bro, I didn't know we can just do count. I didn't know. It's fine. We already did it like this. We already did it. Push if not visited. And position. It can no, it can receive here. It can receive float fill node. It can receive a node, and here node position nodes and maybe reference. I don't know. Okay, it's fine. Yeah, okay. Unnecessary checks this way. Unnecessary checks. What do you mean? It's just one check. Just one check. I suppose this find should be similar to the count function. I suppose it's a set, man. I don't suppose they do linear search. It's a set. They most certainly should be able to do it quickly. Don't worry, bro. It's my project. I can do slop with my project here. It's fine. It's my project that's getting messy. This is bad for me, not for you. Don't worry about it. Let's test it, man. Let's test it. So here we go over all of the and so what's the goal here? What's the goal? We need when will we stop? Here if what should be the distance we stop? What should be the distance we stop? Here it's 0, 1. At this point we're 0. 0, 1, 2, 3, 4, 5. We don't spread after 5. So here if nodes distance, if node distance is less than 5, or if distance equals or if it's greater or equal than 5, we break the while loop. We break. We break. Right, chat? Yeah. If distance is 5, we break. Why 5? Because here, if the water finds here a distance of 5, it prioritizes it. But if it's greater than 5, it will not work. Here, this block is greater than 5. This distance is 6, and it doesn't work. That's why it's 5. It should be 5 at most. That's why. And so what do we do then, chat? Then we need to look below us. Every time, for every node, we need to look below us. We need to look below us. Here. We need to look if node position get let's do position details node below equals node position get down, and here if node below get block type. What if below us it's water source? What if it's water here? What if we have water here? Is it just air? Oh, even if it's water is the same. Interesting. So if it's water or air, if the block below us, we need to save it. Block type below equals get block type. If it's air or if it's water, we need to do something. We have found it. We have found it. If we have this, we have found it. The prioritization. So we'll just break, because that's the goal. We can just break here once we find it. And here we can do position details, missing block, and here boolean found missing block equals false. Here found missing block equals true, and let's save it. Missing block equals note below, like that. We have found it. So here, if we have found it, we do something else, we do something else, and we spread everywhere. If we do not find it, we spread everywhere. We can just test this. Here, currently the logic will spread normally if the terrain is flat. But if it finds a block in a 5x5 region, if it finds missing block like this, it will go there. It will not flow. It will just stay like this. It will stay like that, chat. That's the logic, just so we can test it if it's all right. Oh, my distance starts from 0. That's why I stop when it reaches 5. That's why I stop when it reaches 5. Okay, let's test it first to see the problem. Let's first see the compilation error, because there's always one. There's always a compilation error. Yeah, it's copy. Maybe it's in the hash. Yeah, maybe this is in the set, probably. No, here. Where is this file from? This is in include type traits. Do we have a set here? Set. We have a set here. I'm annoyed to look. No, I want to break, I think. Right, chat? We want to break there, right? Because you are worrying that if we break, we'll probably miss a spot. Here, this error is probably because of the set that we're using here, a vector 3. Probably the set uses hashes, and it needs the vector 3 hash. Probably uses hashes. Can we give it here extra detail, like vector 3, like the vector 3 hash? Can we give it here extra information? We need to look at this. We can do unordered. Oh, bro, unordered set. That's it, chat. Unordered set. Now it should fix it. Yo, Quake, I haven't seen you in a while. What's up, Quake? Yo, look at this chat. Look at this chat. Look at how the spreading stops once it finds missing blocks. That's perfect. Once it finds missing blocks. Like here, look at this chat. This water stops. This is what we did, chat. This is what we did, chat. Now we need to prioritize it. Now we need to like continue here towards the spot it has found. We need to make it continue towards that position. We need to make it continue towards there. We need to make it continue there. But about here, I'm not sure, chat. About here, I'm not sure. Because here, when it stopped, we shouldn't be getting here stopping. This should flow normally, I think. Why you need to store the origin? You stepped from the origin. What do you mean? Oh, chat. Yeah, if we to store the direction. Chat, if we for every child block, we can store for every child block that just the source, the parent. We can just store the parent. Like the parent, the original one, so that we can calculate the distance. And if the distance is greater than 5, we'll ignore this limitation. So the water can continue flowing naturally. Because when the water spreads a lot here, it stops doing the calculations. Once it starts spreading from here, it stops doing the prioritization. It acts normally. Yeah, once it's out, like here, for example, this number 3. Oh no, we don't need to do that, chat. We have the layers naturally. If the water layer is 2 or 1, we don't do the checks. We don't do the checks, maybe. Maybe. Yeah, we'll just use the layers. We'll just do the layers. If the layer is 1 or 2, where the maximus... So if the layer is between 2 and 4, if the layer is 2 or 4, we don't do the calculation. Let's try that. Because here, look at how it stops. And it shouldn't stop like this. It should continue. That was a funny response. Well, Notch at some point had a team. In the beginning, there was a lot of potential in his beta version. And because of the huge potential, like everyone, every player saw the potential. They invested a lot of money into Notch. And so he made a team. At some point, he had a team. He had Mojang. And I'm alone. Yeah, here, this logic, we need to ignore it. We need to ignore this logic. Here, if... do we have current layer? Do we have current layer? Layers. Yeah, layers. If layers is greater than 4 and this. If layers is greater than 4, we'll do this logic. If layers is greater than 4. It still stops. It still stops here. The prioritization algorithm still stops. Oh. If you don't do search for layers, less than some layer, you have no way of detecting where to go for those layers. Chat. Because here we can easily... Okay, let's just do the prioritization. That's a different problem. Let's not solve future problems. Let's solve the current problem. Let's now... we have found a missing place. Let's say we have found this one. Let's say here. So let's prioritize having water flow just down here. Let's just do this, chat. This should be easy. Let's just do this. So here we have found it. We will do the same. The logic is the same. We place blocks. We place water blocks towards the neighbors. Sure. But some neighbors will not get water. We need to figure out which ones. And the only thing we have is the missing block location. Here, this missing block, but let's actually just save node below. Let's save the node above, node position instead. We just need to flow in that direction. So we have a target. This is our target. The missing block. That's the target. The missing block. Target, missing block. And look at this chat. Here, Here is the missing block here, this part. This is the target, and here is the source. I want just to place here water. That's it, chat. How am I going to do this? We have the start and the end. We have both things. We have the start and then how should we implement this, chat? How can we calculate to place a block here? We can, okay, let's subtract the difference between their positions. Let's just do that, chat. Let's just do that. Vector 3 difference equals, let's do vector 3 subtract. Let's subtract the position details block origin with the missing block origin, like that, and we normalize it. Vector 3 normalize. We normalize it. That's how we're going to do it. That's how we are going to do it. And if like the z is +1, we prioritize the north. If z is -1, we prioritize just the south. If it's diagonal, we do both of them. Something like that. Something like that. But the difference, did I subtract them the right way? The start minus the end, or should it be the end minus the start? The direction is important. Vector 3 subtract. I need images. What was the order, chat, here? So this is A minus B. So the start. Oh, so I need to swap them. Because I want the direction to be towards the end. I need to swap them. Let's swap them like this. Perfect. Okay, so we have the direction where we need to go. That's it, chat. We have the direction. So let's do a check. If how are we going to do it, chat? If it's either, the direction is simple. It's either towards just the what if it's here, the center? What if it's here? What if it's like this? It spawns these ones. And here the direction is like this. It spawns these ones. Here the direction is this, spawns these ones. Okay. So it's either when we have water, it's either here, 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 or diagonals, or both of them. But how to write it better? We can do it simply. We can do it simple. Here, if diff x equals 1, else if equals -1, else if z if z is 1 and z is -1. And we need else. This is when it's a diagonal. We need to check which diagonal it is. Here we just want, here we want to place, when it's the x, we want position details get east, let's say, right? Oh, but it wants a reference. What does it want? It wants the reference. Here, when x is positive, what was it, chat? Let me think about it, chat. Here, negative x. Okay, positive x is east. Yeah, this is east. And here we place towards the west. And oh no, we had them here. Yeah, we had them here. So I'll just do it like this. So here Z1 is the south. And -1 is the north. That's -1. This is 1. Here, this is 1. And here, this is -1. This is 0. But we need for the diagonals as well. We have 4 more options. We are covering these options. Each one of these we're covering individually, but we need the diagonals if it's like this, or this, or this, or this. So again, 4 cases. We have 4 cases again. So else if test them before diagonal. Okay, let's test it before diagonal. Let's test it and see what's up. Let's see if it prioritizes. Yeah. Oh, chat. It prioritized. It prioritized, chat. It prioritized. Yeah. But we need diagonals as well, chat. We need diagonals. Yeah, that's cool, chat. And even here it should prioritize. Yeah, it prioritized. Yeah, look at this, chat. It's just like, bro, it's like Minecraft. It's like Minecraft, chat. It prioritized. Oh, that's cool, chat. Yo, chat. Chat! This is the thumbnail. This is a thumbnail, chat. Water is not done, bro. Water is not done. We have a little bit more. Let me change the thumbnail. Okay, I updated the thumbnail. Okay, let's have the neighbors as well. Let's have the neighbors. I don't know what this block is prioritizing. I am not sure. Oh, the water. It's targeting water as well, I think. Center of roof. Yeah, it's still the same stuff. Oh, wait. Oh. Here. Yeah, something happened here with the water. Oh, maybe with the spreading. Yeah, with the spreading. Yeah. Spreading. Nice. Now we need to fix the slight connection between the water layers. Yeah. Just. Let's finish the diagonals as well. Because we are only checking for the northeast, west, south. We need the diagonals as well. Here, if x is negative and z is negative. And we need to do if they're both positive. And if one of it is negative and if the other one is negative. Like that. We'll be placing 2 neighbors. So here we want x is negative, so west, and here Z is negative. Z is negative, so north. Here, it's both of them are the opposite. Here it's east, and here it's south. Here it's west, and here it's east and north, like that. And so here we have -1, or it's like 0.5. I don't know, chat. No, I can just put the difference here, bro. I can just put the difference here. Like that, and we need to change the function here to be vector 3. Be vector 3. Like that. Perfect, chat. Perfect. Yeah, that's perfect. It's a little bit gross, but... Let's test it, chat, and see what's up. Bro, why do you need so many summaries, man? Why do you need so many summaries, chat? Let's test it. Now it should work for the diagonal. Diagonal. When should we get a diagonal, chat? Like, do we get a diagonal direction? Yo, what's happening here, man? We got too much water. Bro, look at this water, how it's flowing straight down. And only here it's traversing. Like, bro, look at this water, man. Now it get... Oh, here, it was diagonal. This was diagonal, chat. Perfect, this was diagonal. This was diagonal, just like Minecraft. Bro, just like Minecraft. It was diagonal here. But here, look at how it continues to prioritize. This is not natural. It continues to prioritize. It continues to prioritize, which is not okay, chat. We need to change this. We need to change that. Only here it started spreading. Yeah, here it... Texture is killing. Yeah, bro, but when I do the fateful texture, then people don't like the fateful texture. There will always be somebody that doesn't like the texture. And let's see what Minecraft does in this case, chat. Like the spreading, chat. What to do about the spread? Let's go in Minecraft. Let's see. Let's try to spawn it in a similar way to see how it reacts, chat. How was it here? Here it was block, then distance 1, 2, 3. So here 1, 2, 3. Oh no, it can be here. 1, 2, 3. Perfect. Let's place it here. Okay. Even here it's doing the same thing as my game. Even here. So here it managed to split. Here it managed to split. Oh, but if it was like this, it would have spread even more, I think. No, it's the same. Interesting. So what's the difference here, chat? What's the difference here for this spread here? When it's like this, why does it spread like that? I'm interested to see. Okay, let's test this case, chat. Let's test it if it's like this. So how does this look like? If it's like what? What was it? Yeah, here. This. If it's like this, let's see how it spreads. It prioritized. It should prioritize differently, chat. Should prioritize differently. Even here when it drops. Yeah, let's test this case. What if it's like yeah, when it's like this. No, chat, it's prioritizing the wrong one. It should prioritize here. It should prioritize here, this block. This is closer. It's prioritizing the longer distance. It's prioritizing here. It's prioritizing here. This is wrong. It should prioritize here. Yeah, it's just prioritizing the wrong spot. That's it. That's it. It's just prioritizing the wrong spot. But it's pretty cool, chat. I like it. Pretty cool. Chat, if it prioritizes the diagonal, it will go towards both. When it prioritizes the diagonal, it will create water here and here. It will create water here and here. This block will create water here. No, this block will prioritize here. And let me test this situation. This is interesting. Let me test this. This is interesting. Right? Like this case. Here we have water. What does it... Oh, yeah. In Minecraft, if it likes this, it should spread everywhere. If it's like this, it spreads everywhere. And that's a mistake. Here, it should spread everywhere. Yeah, it spreads everywhere when it's on top of a block. Yeah, we just need to iron it down. But we're pretty close, chat. We just need to iron it down. Is it possible to quickly fix this? Is it possible, chat? Yeah, but it's pretty cool, chat. Pretty cool. But it should spread, chat. It should spread here when it falls. I think it should spread. Yeah, what if it's like this flat? What if it's like that flat here? What if it's flat? Oh. Oh, what happened here? It's confusing. Yeah, this multiple targets. Yeah, it's a bit weird when there are multiple targets. A bit weird. No. Chat. What if I place it here? Same. If I place it here. Yeah, look at this, chat. It's not multiple targets, chat. It's like this block, this water block just does it a bit different, I think. Like here, it's like, I don't know, chat. I don't know. What problems are you having? I don't know what problem I'm having. I'm not sure, chat. Is the prioritization? Is the prioritization, chat? Like here, we managed to kind of prioritize it, but we're prioritizing it. We're limiting the water too much. We're limiting the water too much. We need to make it more relaxed. We're limiting it too much. Because look at this. This is not natural to spread so perfectly. This is not natural. They do it a little bit different. And only at the end, it spread around. Only at the end. It needs to spread earlier as well. So multiple targets. It's multiple. I don't know how to do multiple targets. Yeah, what if it's like this? What if it's like this? Is there terrain like that somewhere? Here. What if it's like this? Yeah, look at this. It started spreading. But in my game is the same. The difference is if here we have where we fall. Yeah, look at this. It does it just like me. Just like in my game. It went down. Oh, here it prioritized again. Interesting. I think it spreads to the direction if a place on block direction is nil and spreads for 4 sides. Okay, let's test this in my game as well. Here. So we do here like this. Like this. Let's put water. And here it doesn't spread. Why? Why is it not spreading? It's not spreading here. It should go towards here and here, right? Why is it not doing it, chat? That's weird. No, in this case, it has all of the directions. Usually. It just has all of the directions. Usually. Like it should check for here, it's taken, here it's taken, but here it's free, and here it's free. So what I expected was to spread here and here as well. It's acting as if these blocks are taken. That's what's happening. That's very weird. And I don't know why. No, what if you make it when there's no further to fall down? It spreads. Don't worry about chat. Don't worry about it. Well, we did pretty good, chat. We did pretty good. I will do a summary. So today chat voted to implement the water physics, the water liquid physics. We managed to make the water spread too much. We managed to make the water like here. When the surface is flat, the water spreads everywhere. And this spreading towards everywhere was bad when it happened on a mountain, because it was spreading too much. There was water everywhere. And we noticed in Minecraft, it prioritizes a missing block, like here. It prioritizes and it doesn't spread everywhere until it hits a flat surface. That's when it stops prioritizing. When it finds a flat surface. Like this. When it's kind of flat, it manages to spread around. That's what we did in our clone. But if we look at the stream currently, it looks kind of unnatural how flat it is. And if we look at in Minecraft, it manages to spread earlier. It manages to do it way earlier. Like here, if we place it here, look at how it spreads here. Yeah, sometimes it has multiple targets. Maybe when they're equal distance. I don't know. Maybe. Yeah, maybe when they're equal distance. But here, look at how it continues to spread naturally. And at the end, it spreads everywhere. Just like in my game. At the end, it spreads everywhere. But I need to make it a little bit more natural. Maybe with multiple targets. We'll see. And we also need to fix the mesh. These gaps, we need to fill them up. We need to fill up the gaps, and we need to fix the animations to follow the flow direction. Follow the flow direction. Right, chat? Anything else that happened? Chat? Yeah, I think that's it, chat. Where's chat? Yeah. So that's kind of a summary. Like before, when we placed water here, when we placed water, it filled up everything. And now it prioritizes. And sometimes here it stops. I don't know why it stops. It should continue to flow. Sometimes it stops. I don't know why. But here it manages to continue down. There are some bugs we need to fix, but we're pretty close to having water. We're pretty close, chat. We're pretty close, chat. But we had good progress today, chat. And look at how here it's flowing down. This is cool. This flow animation. This is cool, chat. Yeah, that's cool. Yeah, so that's it for today, chat. Thank you for watching. Thank you for watching, chat. And bye, guys. I'll see you probably tomorrow. This was a good stream. We did a lot of progress. Oh yeah, and also when waters interact, when they collide, they interact here. Look at how it continues to fill them up when we add more water. It increases the other water. That's cool. It adds to the other water. Like here. Look at how it increases it when they interact. That's cool. Yeah, so that's it. Bye, chat. Bye. I have 3-hour time limit, so I don't burn out and manage to stream tomorrow as well. That's why I have the 3-hour time limit. Yeah, bye, guys.